So today I'm going to be showing you or reviewing for you how to graph linear inequalities. This may not be a familiar skill. This may be the first time you're seeing it. That's okay. I'm going to walk you through the steps slowly. I'd like you to try the guided practice on the back page when you're done. So it's very similar to graphing a line, except an inequality has a shaded region as a solution because there are multiple solutions that will all satisfy an inequality. So first we're going to write our equation in slope-intercept form. Then we're going to determine if we should have a dotted or solid line. So the way we do that is dotted lines are going to be whenever you have a strictly greater than or strictly less than symbol. And a solid line is when you're going to see the greater than or equal to, less than or equal to symbol. So here, then you're going to graph your line and test a point. So I'm going to show you, I don't always test a point. I just read the inequality. So I'm going to show you what that means as well. So here is my first inequality. And I can see that it's a less than symbol. So I'm going to be using a dotted line. And my slope-intercept form would just be y equals 2/3 x minus 4. So it's a line through -4 with a slope of 2/3. But I want it to be a dotted line. So I start at -4 on the y-axis, up to over 3, down to over 3. It has a positive slope. I'm going to dot that line in all the way across my axis. Now let's read this inequality together. Y is less than 2/3 x minus 4. Well, are these y values less than that line, or are these y values less than that line? These y values are. So you're actually going to shade your solution region below the line. The other method says to test a point and determine where to shade your inequality. I always like testing the point 0, 0 because it's easy to plug in. As long as your line doesn't go through 0, 0, I would just use 0, 0. If not, pick a different point. If I plug in 0 up here, is 0 less than -4? Because if I plug in 0 here, I just get -4 on this side. No, that's false, right? 0 is not less than -4. So 0 is not one of the solution points. All of the solution points lie below the line. If 0 had worked and made a true statement, you would have shaded above to include 0, 0 as one of your solutions. So the next inequality, I'm going to use a solid line for because I see a greater than or equal to symbol. Slope-intercept form, y equals x plus 1. So this has a slope of 1 over 1, and it goes through 1 on the y-axis. So here's 1 on the y-axis, and I'm going to go up 1 over 1 for a positive slope. It might be helpful to use a ruler to get your line straight. I don't have a ruler, so I'm just going to dot in a bunch more dots. That way I know that I'm going as straight as I can. So solid line. Let's read this inequality. Y is bigger than x plus 1. Well, aren't these y values bigger and these y values smaller? So in this case, I want to shade above the line. So let me show you a point that would satisfy the inequality. How about the point 1, 10? So if I plug in 1, 10 up here, I get that 10 is greater than or equal to 2, which is a true statement. So that should lie in the solution region, and it does. All right, so the next inequality is going to be a solid line. Y is less than or equal to 8, and we would write it as y equals 8. Well, what kind of a line is that? That is a horizontal line at 8. It is solid, and you're going to shade below. So in that direction. All right, and the next one is going to be a dotted x equals 0, which is a dotted vertical line at 0, and x is strictly greater than 0. So I would shade in this direction, right? X is bigger than 0. Isn't 4 or 6 or 8 bigger than 0? So I was going to have you submit a picture of this back page, but let's graph these systems together, and then maybe you can try like one problem on your own at the end. So this is just graphing two inequalities on the same axis. I'm going to do them in two different colors so that you can see the overlapping region. So this is the equation y equals negative 2x plus 4. So I'm going to go to 4 on the y-axis. I'm going to go down 2 over 1. All right, so this was the negative slope. So I'm going to draw a solid line in. This says y is less than or equal to the line, so the y values that are smaller are down here. So I have a purple region, but now I need to graph this inequality because it's another part of the answer at x equals 1. So that's a vertical line that's dotted at 1. So which side should I shade on? This says x has to be bigger than 1. So the red region would actually be all of this part over here. So there's something called a feasible region. So the feasible region is where you have red and purple at the same time. So if I shade it just a little bit darker so you can see, right, that right there, that section of the triangle all the way up to here, but this is all the feasible region. So that's my solution to the inequality. So example 2, I need to do my two different lines. So I'm going to do this first example. Divide by 2 on both sides. Y is less than or equal to negative 2x. That is going to be a solid line through the origin with a slope of down 2 over 1. Solid line through the origin, slope of negative 2. Y is less than or equal to that line. So I'm going to shade below the line. So in red, I'm going to graph the line y equals x, and that's also going to be dotted this time. Through the origin, the slope is up 1 over 1. Up 1 over 1, up 1 over 1. Y is bigger than the line, so I'm going to shade above the red line, and I can see where my regions overlap. Here they're overlapping, right? So that is the feasible region. So I'm going to do number 3, and then maybe you can just submit your work for number 4 today. Show me that you attempted that one, and we can see what questions you have. So I'm going to do example 3. Here's a trick that you might not know or might not remember. When you divide an inequality by a negative number, did you know that you actually have to flip the inequality sign around the other direction? So we've got negative 1/2 x minus 2. So y equals negative 1/2 x minus 2. It's going to be a solid line. So I'm going to go to negative 2 and go down 1 over 2. Maybe you want to pause the rest of this video and see if you can shade it in the correct feasible region. That would be a good idea to practice. So there's my purple line. Y is bigger than, so I'm going to shade above the purple line. And now I'm going to do this other line in red. So if I go to y equals 3x minus 1 dotted, I'm going to start at negative 1, up 3 over 1, up 3 over 1, down 3 over 1, dotted line. Y is less than the line, so I'm shading here. So I'm looking for that overlapping region. So here is the overlapping region. And I think I might go ahead and just complete the final problem because I think it might be a tricky one. So y equals x plus 2. So I'm going to start at 2 on the y-axis, and I'm going to have a slope of 1, and I'm going to do a dotted line here. So this says y is everything less than that purple line right below it. All right, well, what happens in this line is when I move the x to the other side, I get y is greater than x plus 4. So I start at 4 on the y-axis, and I do another dotted line with a slope of 1. What kind of lines are these? They're parallel, right? Well, aren't I shading above the red line? So is there any intersection point between the purple and red? No. So there's actually no solution to this set of inequalities. So you should have all the right answers. So could you just take a picture of this page and hold it up so I know that you got through these notes today? Thank you.